Today we are going to see the field exposure of Mathanomid formation. It is in tertiary, lying above the Deccan traps, and it consists of trap wash and withered basalt product. This is a close-up view of the section that is which exposes the Mathanomid formation, and here we are hardly 800 meters from the original place. Here the sections are exposed as a cliff along a small river channel. It gives the idea about the thickness of Mathanomid formation, which is usually not seen in the original type section. Here you have various bedded structures of trap wash consisting of fine grained material, withered product, and it shows cross stratifications. This cross stratification that we are looking, we are viewing towards the east, and the angle of cross stratification or the paleocurrent direction points towards the north. We have measured it and it shows north. This indicate that this was the result of Deccan and all weathering aspect of the rivers flowing on all four sides of Deccan highland. This is one small cross stratification which shows northern dipping laminas indicating paleoflow towards the north. This is the western section, and what you see are different layers that are yellowish, orangish, reddish, consisting of various weathered product. What I suspect here in the upper part, this might be some trace fossils, may be indicative of fluvial origin. This is an entire view of the section from 5 meters below, and what we see is the basal part consists of shales. These are shales which are going up right up. It also contains few bands of mudstone and few siltstone, but conspicuously they are upwrapping the other weathered system. This is the extension of the same section, and if you take a very close up look of the shales we have just now discussed, I can see some of this ferruginized lining. They appear to be indicative of trace fossils or bioturbation. Typically, what we see here is a Y-shaped structure, and towards this we have a U-shaped structure. You have some kind of bulb which is going, and you have a very long extended burrow. This long extended burrow, I feel that it might be a root structure. So these shales and mudstones that we see in this lower part of the unit, I feel they are bioturbated and then they are later on colonized by plants. This is the section we are looking, is we are viewing in the northern direction. So what you're looking is a east-west oriented section, and paleoflow, as we have discussed earlier, it's towards the north. You have here at the base a very thick sequence, approximately 6 to 8 feet of shale sequence overlain by units which are having cross stratification and clay nodules. These are the units which are considered as trap wash, and in some areas we could see some kind of pause plains or hard grounds, not exactly hard grounds, but what we can see are ferruginized layers. In some of the mudstones in the lower part of the section, they are capped with ferricrete or iron, like this. This is not even, they are undulating. Their thickness is also not uniform. They are few centimeter thick, around 10 to 12 centimeter. Somewhere they are very thin, up till 2 or 3 centimeter. This thin black layer that we see here, when we take a fresh sample of this, I'll take up a close up. It has lot of organic matter, probably very low grade of lignitic material can be there. That was earlier section that we have discussed. When I came here, this shows a very interesting locality. What we have at this uneven profile here is a weathering profile, but at the top, the clays that you see are part of the channel that we had discussed earlier. This clays, they wedge out here, but as they go towards the south, they thicken up and they form a kind of channel structure. The end of the channel is where I have shown you earlier. This is a close-up of the shales that we have just discussed. They show thin layering between shales, and it goes up with some kind of weathered clast, which are weathered into clay balls. Again, it alternates with clay. Most probably, this is a kaolinitic material, and then slowly it goes to ferry crust. So this crust, this is a very hard Fe layer which is there, and what we feel is that this kind of Fe layers, they might indicate separate fluvial stages. Here you can see how one end of the channel it appears, how this entire clay and sand, it pinches out into a very thin layer. It goes and end up here. This is a close-up of the one of the sandier material, and as we can see here, there are several quartz fragments which are angular to subangular in nature. This is a poorly sorted sand, but as we go up here, typically where I'm pointing my finger, this has completely converted into clay. Okay, so these kind of balls, that is weathered product, they are very common in this upper unit. Lower unit consists of poorly sorted angular to subangular cords and some ferruginous material, and of course there are other clasts also. But this kind of walls are very common in the upper sequence. These are my students coming for field study. He is asking where he is. Yes. Now they are asking what kind of this powder material is. So first they have to study this. Then we will discuss what it is. This is Dhruv. These are all petroleum engineers from BTech, and their main task is to understand, identify lithology, depositional environment. So today we have brought them in an area where they will study how weathering occurs and how weathered basalts or clays uh, and other such derivatives they can be identified in field. There are nearly 140 students, so moving them from one location to other is also a Hercules task. As you can see,